focused on applying analytics techniques to provide security monitoring for cloud-based applications. Previously, she was a chief scientist for security for Dell, where she kind of developed and implemented their security research strategy. And so she has won in 2010 like a CSO Magazine's Women of Influence Award. And in 2015, Computer Business Review voted her as one of the 5 women leading the way in cybersecurity. So looking forward to your talk.
Thank you. All right, thanks, Jan. My presentation is going to be a little bit different in that what I want to do is take a very high-level view of where we are right now in applying machine learning to intrusion detection technologies in the industry, and how have those been integrated so far. I take a very broad view when I say intrusion detection systems of what that means. I am looking not just at a person who has tried to intrude on a system, but also software trying to intrude on a system. I realize it is a broad definition. It means an awful lot of different technologies fall under that category. In industry, no one says, I build an intrusion detection system. No one said that for over a decade. People will say, we'll go much more specific. I build a malware detection system. I build a system to detect compromised credentials. But all of them ultimately are looking at intrusions. And so I'm taking a higher level viewpoint of this. When I'm talking about machine learning technologies being applied, what we see typically are 2 different approaches. One is classification and the other is anomaly detection. Classification means that you have a data set and that you've trained, that data set has good behavior and bad behavior, and you've trained on that behavior to be able to recognize in the future good from bad. Anomaly detection means that you've tried to categorize all of the normal behavior on a system, and anything that deviates from what you've seen as normal, anything that's anomalous, is therefore flagged as being malicious. And what I argue is that we really want to go towards what I call opinionated security. It's really an explanatory machine learning. You want to have what Rachel was mentioning, interpretability. You want to be able to understand why a decision was made. So where is it that we apply intrusion detection systems? If you look across the space of what you can, what a user does. You start at the client level. You're using your laptop, your desktop, your mobile device. From there, you want to access, for example, a website and some application on a website. You're going to go through a network router, you're going to hit a firewall, authentication servers, finally hit the web server, and then there'll be applications on that web server. And it might be local at your organization, or it might be that you're going to a cloud-based service such as Salesforce or Dropbox or Slack, in which case things are not necessarily lined up as neatly as on this graph, but it gives you an idea of a basic flow. We put intrusion detection systems at a number of different places then. And I'm going to start with talking about at the client space. What is it we can look at there? In this case, you're looking on the client itself. That means that you're typically looking at files. You're looking to see, has anything malicious been put on this device? What I consider to be the canonical paper in this space for looking at machine learning applied to intrusion detection at the host level is a 1997 paper, A Sense of Self for Unix Processes. And essentially what this paper did is it looked at Unix and it said, it took 2 particular processes, sendmail and LPR, and said, can we determine what would be normal behavior for this, and then recognize if someone is trying to do, for example, a buffer overflow. They consider it normal to be that sense of self, and they consider that misuse to be an attack on the system, so not self. And the way they did this is by looking at a series of commands. So all the different system calls made by sendmail or by LPR. And they found that they could restrict it to a length of 6 system calls that were considered normal, and there were a lot of consistency actually. It was there wasn't a lot of deviation in those sequences. And they were able to therefore map, and if someone did an attack, it would deviate. So for example, if they saw a read, read, write all the time, and then suddenly they saw a read, write, read, that would be considered unusual, and so they would flag that as anomalous. So it was an anomaly detection approach, and it worked quite well. What's happening in industry right now when it comes to machine learning? So a lot of malware detection, we're familiar with typical AV, Symantec and such. Cylance is a typical AV company, and well, it's looking for malicious files, so it's typical in that sense. They've actually applied machine learning techniques, and they're doing extremely well right now. They finished Series D, I think maybe a year ago. The way they do this is they've taken millions of files and classified them as either good or bad based on over 100 different features. And from this, they've been able to get a very high true positive rate and a very low false positive rate, and they're being very successful. But they took a classification approach. Neutron, which is another startup, more recent startup, they've just received $20 million in funding, takes a different approach. It's much more of an anomaly detection approach, and it's very related actually to the sense of self. They took an operating system, Windows, and said, what are all the normal pathways to use this operating system? So if I go to delete a file, you can say, all right, the normal process for deleting a file is someone's using the machine, they'll drag the mouse to some place, they'll right-click, they'll drag down, they'll hit delete. And this series of steps generates a series of system calls. And if there is malware on your device that's trying to delete files, it won't go through that normal series of steps. And so they've classified what's normal for the system. And again, they've been able to do this with a fairly, very low false positive rate and a very high true positive rate. So that's what's happening at the host level. What are we seeing at the network level? If we're looking at network IDS, we're monitoring a different location now. So instead of operating on the end host and saying, what are all the files that I'm seeing that might be malicious, I'm going to look at all the network traffic going across my network and say, can I detect there that something malicious is happening? Someone is intruding on my system, someone's installed a bot, or whatever the case may be. This goes back to the absolutely canonical paper, in my opinion, for applying machine learning to intrusion detection, and that's an intrusion detection model. This is a paper by Dorothy Denning in 1987, and she looked at applying anomaly detection and said, okay, can we define normal, and if anything falls outside of this model, it's anomalous and therefore malicious. 23 years later, Robin Sumner and Vern Paxson wrote a paper, Outside the Closed World. And what they did is they looked at network intrusion detection systems and applying machine learning techniques and said, why hasn't it worked? Why is it that we have a lot of research in the academic community in this space, a ton of research, and yet it doesn't really seem to be successful and moving out into industry and being used? And where is it failing? And they found it was failing due to a number of different reasons and problems. One is looking at network traffic. What we tend to do is say, look at traffic patterns. So we're looking at, say, packet headers or flow data, and the traffic patterns and trying to say what is normal for a network. Well, what's normal for a university campus, for example, is not necessarily normal for the NSA. And so you can't necessarily say this is normal traffic and that's going to translate across all of these different environments. Even just within a campus, you can't easily say this is normal because there's a huge diversity in network traffic. And so typically our approach has been, can we define some kind of model and then say what's anomalous? And then when we look at what's anomalous, we make this assumption, anomalous is malicious. And that's not necessarily the case either. So we tend to have a lot of false positives when taking this particular approach. And so we've seen that it hasn't really worked well. And then a final thing, or not a final thing, but another thing here is how do you evaluate? How do you say that something works well in this kind of setting because you don't have the data to then say, you don't have ground truth. If I take the case of classification with hosts, I can have all of these malicious files, I have all of these known and non-malicious files. I have ground truth. In this case, I'm looking at network traffic on a campus network or wherever it may be. I can't tell what is actually normal and what's actually malicious, so I can't actually judge how well I'm performing. And then there's a cost. If I start actually implementing based on what I'm seeing, I can block something. I can say that looks like a malicious host and block them. If I'm wrong, there's a high cost to doing that. And so I need to have a very high accuracy in my system, and we haven't been seeing those accuracies yet in the systems we've seen. Having said that, is there anything in industry? And there is one company I did find in industry that claims to be doing machine learning and network intrusion detection systems. This is Blue Vector. If I remember correctly, they spun off about 5 years ago from Northrop Grumman. If you look at what they're doing, they actually have scoped themselves differently. They're doing deep packet inspection. And so they're looking for malicious files. So you're going back to a case where you have known bad and can do a better job of doing classification rather than anomaly detection. And that's why they're seeing success, is because they scope themselves differently than what we've typically seen within the academic environment. So where else can we apply intrusion detection approaches? SIEMs are extremely popular right now. Security Information Event Management Systems. A canonical example here is Splunk. In the freeware space, it's the ELK stack, Elasticsearch, Logstash, and Kibana. And what this is it's taking log files from everywhere they can grab log files. So you have your network traffic, you have firewall logs, authentication servers, your web server logs, everything going into a single location, which is great because now you have all of this data and you can look through it and say, all right, what's happening in here? And there is, I haven't noticed any academic papers that really look at this, but that's possible I've just missed some. But what I'm seeing in industry is companies like Spida, which was acquired, another startup again, was acquired by Splunk, I think 2 years ago. And it's looking at what's called user and entity behavioral analytics, UEBA. Their approach, instead of doing classification or anomaly detection on files or network traffic, is to try to model users. And they're saying, all right, what is the typical behavior for this particular user, and has that person deviated at all? And what is the particular behavior of this user as compared to their peer group? And so it might be the case that the user is doing something that might be kind of normal for them, but you look across and go, everyone else that sort of that they should be similar to is not doing this at all, and why is it that they're doing that? They're doing the same kind of approach, not just on users, but trying to model what happens with different, they call them entities. The entity could be, for example, a device. What is the fingerprint for the typical behavior for that device? And now doing anomaly detection on what that particular, that activity is. And then other places I can apply an intrusion detection system is at the application layer. What do I mean by the application layer in this case? I'm thinking about things like cloud applications, so your Salesforce, your Slack, your Dropbox, Gmail. And you can monitor the APIs that are happening on the application and again, develop models. And what we're seeing, this is called in industry the CASB space, Cloud Access Security Brokers. Traditionally been very, very policy-based, very compliance-based. So, someone is logged in from 2 locations at the same time, we need to block that. It's starting to move now into more of a user modeling space. There's been a lot more UBA applied to it. For some reason, which is kind of weird, UBA was really, really popular a couple of years ago with VCs, but hasn't really shown the promise that people thought it would, and I'm not sure what's happened there. Recently, there's been a company called Elastic Beam that's come out, and they describe themselves as doing AI-powered API security. What they're doing is they're looking at APIs, and they have a self-learning approach to understanding your environment, because again, your environments are going to differ based on what application you're actually monitoring. Learning that environment and then saying it's something as anomalous. And they claim to be able to detect, for example, compromised credentials from this, DDoS attacks, which should not hopefully be that difficult, data exfiltration, a number of different types of attacks by using an AI-powered approach. Unfortunately, one of the things I found when looking at all these different companies, I've mentioned that they do classification or anomaly detection. I can't give you details on how they do any of that, but of course that's their secret sauce. So at a high level, I can tell you Elastic Beam claims to do self-learning on it. That gives me an idea that it's going to be some sort of anomaly detection, but the examples, the deep dive examples, are not really existing. So what is the similarity across all of this space, and looking at the different ways that machine learning have been applied in this space? All of the companies that I've mentioned are all startups. It's a very, very new space. There isn't a lot of, I can't stand here and say, oh, IBM's been doing this for 20 years. The products all seem to be very, very new. Why is that the case? I think we're finally hitting a point where our technologies, a couple of things have happened. One, our technology is getting good enough that we can get the accuracy that we need. And 2, we're starting to scope the problem to get the accuracy that we need. So for host-based IDS, if I have my AV system, I have a malicious file, I want to have it blocked right away, and I've got a high enough accuracy that blocking that is great. And if I block something that I shouldn't have blocked, it's not as big a deal as, for example, a user. If I have a user and I think, oh, this person's actually a compromised account, lock them out, and it's not a compromised account, and it's your CEO or something, this could be a big issue. And so this is why I think you're seeing, like host-based IDS, we're seeing a lot of success with machine learning. As you go through, other places are using machine learning, but there's more of a hesitancy to use it immediately for blocking. Instead, what you tend to see are interfaces like this. One of the things that I found VCs really like to see, and anytime you go to a conference like RSA, People really want to see sexy dashboards. And so you get things with lots and lots of graphs and such. But the question to me is, what information are you actually giving to someone with something like this that's actionable? The dashboards are great because then you can do reports easily and push them up to your CISO or something. But I want to know, has an account been compromised, yes or no? How much do you believe that it has, and why has it been? So I've been calling this opinionated security. I stole the term from opinionated software development, where programming languages are being seen as having their own, the development of new programming languages builds into them this opinion on how you should write code. So it took the same idea and said, okay, for security should build into it an opinion on what has happened and why. And we should have this way of interpreting the results. So, all right, I've blocked an account. I've blocked Bob Smith. Why have I blocked Bob Smith? I think there's a 79% chance of compromise. It's machine learning. It's never going to be a binary 0 or 100%. Oftentimes you're going to have some kind of gray area. Here's a gray area, but I blocked them because it's a high enough level. Why did I block this account? Well, I took a Slack example here. There's an unusual amount of channel browsing. So they went through a number of different channels all at the same time. Why did they do that? 8 read messages were set back to unread. How often do you go on Slack, read something, and then click it back to unread to go back and reread again later? It's not a common activity. Excessive scrolling through history on 2 different channels. Why was it that they were scrolling back so far in these particular channels? What were they looking? Were they just looking for something and it was legitimate? It's not common that they do that, so it was something that contributed to flagging this as a compromise. What is their score then relative to others? Because maybe a lot of people have a 79% chance of compromise, and this actually isn't an unusual number. Well, normally people are down around 25%. We would have expected Bob to be down around that level, and he shot up to 79. How do other people look? Is he unusual compared to other people? Yes, he is. So it's providing an explanation for why is it that we've made this decision? Why do you need the explanation? What happens if you block an account and someone comes in and says, why have you blocked me? You're able to go back and say, well, look, we think you've been compromised. Here are the reasons. And that person can say, no, that actually was me, and here's why. So you can unlock them. Or they can say, oh, my gosh, OK, I'll go and change all my passwords. And so you can have the system set up to respond that way. Another reason is for forensics. If something has happened and you need to then work with law enforcement, for example, you can go back and say, here's why we thought what we thought. Here's why these particular actions were taken, as opposed to having a black box that just says, yes, we blocked this, or no, we didn't block this. The black box approach works very, very well with blocking files, but when it comes to talking about users or data exfiltration or anything that's a little bit more fuzzy, what you really want to do is have some explanation as to why that fuzz was anomalous enough for you to push things over the edge and block something. So it's basically a high-level overview of where the how machine learning is happening in the intrusion detection space right now. Again, very broad definition of intrusion detection. What are the takeaways? And I have 2 main takeaways. One, this integration between machine learning and IDS, even though it's been decades in the academic literature, is really just emerging in the industry space. It's really just starting to go out there. If anyone wants to start a company, VCs love this combination of machine learning and cybersecurity. It's actually a very hot term right now. And we also need to move to a model where we say why something is happening. We can't just have a black box model anymore, especially when we're starting to deal with users. We have to be able to come back and have an explanation for why we're doing particular actions within the security space. And with that, thank you. I think I might have time for 1 or 2 questions.
Thank you so much. Any questions?
So I have a question on the host side.
Yeah.
There have been some other developments that look at it way deeper than just files. And I'm wondering, has there been any machine learning that looks at the actual kernel mods, root user privilege separations, and different kinds of attacks like injecting runtime code, those types of things? Because there's at least a couple companies out there that I know that have IDS that actually monitors at a kernel level, kind of an agent level.
So the Neutron actually models at the system call level. So it would catch a lot of those kinds of things. And again, trying to map out, here's what the normal series of system calls would be, and if someone's trying to do some sort of an injection attack, it would show up as an abnormal series of system calls. That's the one that comes to mind right now. I don't, by any stretch, claim to know all the startups out there. So there may be others, but the ones that have been sort of gaining popularity, that would be one of the ones that comes to mind for that.
Okay. Okay, one more question.
So one of the interesting things about black box versus reasoned arguments is that the black box seems to me to be a security by obscurity argument. And that it can't be integrated with threat modeling. So I have to say so what is actually under the control of the attacker is, for example, the content on a web page. So if you come up with a really good distinguishing machine learning approach for content on the web page, that they can change. So, and it has seemed to me that, however, black box has been much more popular over the past few years. And I've enjoyed your talk, but I still don't understand the embrace of this kind of DNN, black box, hidden variable approach.
Other than the fact that neural networks are cool, I think some of the embrace, well, one comes from a proprietary background and standpoint. So, for example, the Cylance does a strict classification. It's a black box. And if someone gets a copy of Cylance and they can try to write their code, it writes some malware that doesn't look like other malware and can test to see if it will get by Cylance's defenses. I'm not sure why the embrace of the black box, which is one of the reasons I argue that we should actually go to something that gives explanations for why we're doing things. Other than I think a lot of the machine learning techniques themselves lend themselves to black box approaches. Again, I go back to neural networks, deep learning. I love neural networks, but I can't tell you, once it classifies something as a yes or a no, I can't tell you why it made that classification, and the scientist in me is really bugged by that. And again, I'm really not sure why we have that embrace beyond something in our DNA that says, hey, that's a really cool technology.
Okay, unfortunately, that's all the time we have. Let's us thank Carrie again.